For thousands of years, humanity has looked toward the night sky with a single question lingering in the background. How did everything begin? Every generation built larger telescopes, searched farther into space, and uncovered new pieces of the cosmic puzzle. Yet the earliest moments of the universe remained hidden behind a veil of time. Then the James Webb Space Telescope changed everything. Positioned nearly 1 million miles from Earth, Webb observes the universe from a location where sunlight, Earth, and the Moon remain safely behind its enormous protective shield. With its massive gold-coated mirror and ultra-sensitive infrared instruments, the telescope is capable of capturing light that has traveled across the cosmos for more than 13 billion years. Every faint signal it records is more than just light. It is a message sent from an era when the universe was still taking its first steps. During one remarkable observation, Webb focused on a distant galaxy catalogued by astronomers as one of the earliest ever discovered. The light reaching its instruments began its journey less than 300 million years after the Big Bang, making it one of the oldest snapshots of the universe ever captured. What scientists expected to see was a small, primitive collection of young stars. Instead, they found something surprisingly mature. The galaxy already contained an enormous amount of mass packed into a relatively compact region. Brilliant clusters of hot young stars were producing extraordinary amounts of energy, illuminating the surrounding darkness with intense radiation. For a galaxy born so early in cosmic history, it appeared to have evolved far faster than existing models had predicted. Yet the greatest surprise was not its brightness. When astronomers carefully examined the galaxy's spectrum, they discovered clear chemical signatures of oxygen. At first glance, oxygen might not seem remarkable. After all, it is one of the most common elements on Earth. But in the infant universe, oxygen should have been extremely rare. Immediately after the Big Bang, the universe consisted almost entirely of hydrogen and helium. Heavier elements such as oxygen, carbon, silicon, and iron could only be created inside stars through nuclear fusion. Those elements were released into space only after massive stars reached the end of their lives and exploded as supernovae. Finding oxygen inside such a young galaxy suggests that multiple generations of stars had already formed, evolved, and died within an astonishingly short period of cosmic time. This discovery hints that the young universe may have matured much faster than scientists once believed. Instead of a slow and gradual process lasting billions of years, early galaxies may have undergone explosive bursts of star formation almost immediately after the first structures appeared. Massive stars formed rapidly, burned through their fuel in only a few million years, and ended their lives in violent explosions that enriched surrounding clouds with heavier elements. Those newly created elements then became the building blocks for another generation of stars, accelerating the chemical evolution of entire galaxies. In other words, Webb may be witnessing one of the first great factories of cosmic chemistry, where the ingredients required for planets, and eventually life, were already beginning to emerge surprisingly early in the universe's history. After revealing this extraordinary glimpse into the distant past, Webb turned its attention toward an entirely different kind of object much closer to our own galactic neighborhood. Instead of observing a brilliant galaxy, the telescope studied a faint brown dwarf quietly drifting through space. Brown dwarfs occupy a fascinating middle ground between planets and stars. They possess more mass than giant planets, yet they are too small to sustain the continuous nuclear fusion that powers true stars. For decades they were often described simply as failed stars. Webb revealed that they are far more complex than anyone expected. Its infrared instruments detected water vapor, methane, and other molecules swirling through dense atmospheric layers. Subtle changes in brightness suggested enormous storms moving across the object's surface, creating weather systems unlike anything found in our own solar system. Even more intriguing were faint glowing regions high above the atmosphere. These luminous patterns resembled auroras similar to Earth's northern and southern lights, indicating powerful magnetic activity occurring around the brown dwarf. Some researchers believe these displays could even be influenced by an unseen companion object whose gravitational or magnetic interaction produces these ghostly emissions. If that interpretation proves correct, the hidden companion would not be discovered by direct observation, but through the subtle fingerprints it leaves behind. Sometimes the universe reveals its secrets not by showing an object itself, but by exposing the invisible effects it creates.